right, good day, everyone. And then let me quickly mention about the homework assignment, right? I think I mentioned that already in the past. And for your homework assignments, I recommend you guys, using either the Microsoft Word or the Excel, right, to complete it. Since you are learning Excel, so it's better to use the Microsoft Excel, and you can save all the work, right, from each section and put into the Excel, and then later on submit it as an Excel file or PDF file, right? You can easily convert the Excel file to PDF file, or you can use Microsoft Word, right, as to do your homework, and later on, if you want to convert it to a PDF file, you can also do that. I think that'll be easier, in terms of submitting your homework assignment. It's the first assignment is due from chapter 2 and 3. It's due on the week number 5, right? But I will keep you posted as we go by. All right. Any question before we get started? Okay. All right. I think we on section 1.6. Did we complete the section 1.6? Let me double check. Okay, so that opened the PowerPoint for section 1.6, and let's go over some of the contents here. I think I didn't complete this one yet, but let's complete that. Okay, and somewhere along the way. I haven't finished yet. Yep. Okay. All right. So let's continue where we left off from last class, and let's start with this. Okay. So this using the standard form, graphing with the intercept, right? So basically, you have a standard form. This is what we call the standard form. It's in the AX plus BY, right? Equals C. This is what we call the standard form. If the linear equation appear in this form, it's best to use X-Y-intercept. So the first thing is finding the X-intercept. In order to do that, set Y equal to 0. So right here, yeah, find X-intercept, set Y equal to 0. So that means a negative 2x plus 3 times 0. So Y becomes 0 and equal to 12. So now we get negative 2x equal to 12. And from there, we divide negative 2 from both sides of the equation.
I don't think you shared your screen.
Oh, I haven't, right? Okay. Sorry about that. Okay, let me share that. Can you see the screen now?
Yeah, now we can.
Yeah. How about, yeah, do you see the some handwritten note? Okay.
Yeah, we do.
Okay, very good. Perfect. So here you go. This is a linear equation we're talking about in the standard form. And then we try to graph it, right? Before we can graph it, we need to get an X-Y-intercept. So in order to get X-intercept, we're setting Y equal to 0. That means replace Y with the 0 in the original equation. So we have negative 2x plus 3 times 0 equal 12. Now 3 times 0 is 0, so we omit it. So we get negative 2x equal to 12. And then from there, we divide negative 2 from both sides of the equation. We cancel the negative 2x equal to negative 6. So we find the X-intercept, right, in order pair. So X coordinate is negative 6, Y coordinate is 0. Okay, we have that. Then this next step is find the Y-intercept. So in order to find the Y-intercept, we set X equals 0. And we replace X here with the 0. So we get negative 2 times 0, adding 3Y equal to 12. So now from there, negative 2 times 0 is 0, 0 plus 3Y equal to 12. So from there, we get 3y equal to 12. Then we divide both sides of the equation by 3 to get a y value. So y equal to 4. So the y-intercept as an order pair will be 0, 4. So now next thing, we just have to plug in the both x-intercept, y-intercept on the Cartesian system. So x-intercept is located on the x-axis, so it turned out to be here, right here. And the y-intercept is located on the y-axis, so it's right here. So now once you locate those two the points on the Cartesian system, you can just connect it, right? Extend in both directions. Then you actually get a straight line. And then you can just mark this, label this as negative 2x plus 3y equal to 12. Okay. And x-y-intercept works the best when we have a linear equation in the standard form, right? That's why I want to point out that, so you have a clear idea when to use x-y-intercept, when to use slope and y-intercept. Any question on this? Okay, very good. So now, okay, let's move on to the next question. So which method is easiest to graph linear equation in standard form like that? Will be the one, right? This one. Okay, x-y-intercept, right? Just as we just demonstrate, any equation appear in this form, this is always the best. It's the easiest thing to do, right? Okay. And we also have point slope form. Okay, we knowing the slope, right? Slope m. We also have a given order pair, a point given in the x1, y1. And this is best to use the point slope form. Okay. When these two are given, then use the point slope form. Right? It's most convenient to generate the linear equation. Okay, and then also a graph of, yeah. So for example, let's say we are given this, we are given the slope, we are given a point, right? So this is typically settings for this point slope form. So we replace, so using the point slope form here, replace, this is x1, y1, and slope is given. So we plug in the slope, slope goes here, x1, y1 goes here, right? X1 goes here, y1 goes here. Now you come up with this particular form, right? Y minus 3 equal negative half, x minus 4. And that, if you want to expand it and simplify, we can do that, right? So y minus 3 equals negative half x. Negative half times negative 4 becomes positive 2. Now, if you want to add both sides of the equation by 3, you can do that. Then we cancel that, y equals negative half x, adding 5, right? So it's in the slope intercept form. Here, slope is negative half, y-intercept is 5. Y-intercept is 5, yes, b equal to 5. Okay. Yeah, so we have that. Okay. Yep, so then you sketch a graph, it look like that. Okay. So now let's take a look at following thing, right? So write a slope intercept form for the equation of the line passing through 2 points. Okay, so you are given 2 order pairs, and you want to use a slope intercept form to represent the equation, linear equation. So step number 1, you're going to find the slope. So you label this x1, y1, x2, y2. Okay, so the slope equal to y2 minus y1 over x2 minus x1. Now again, plugging all the numbers, so it's 5 minus 3 on top. Y2 is 5, y1 is 3, x2 is negative 2, x1 is 4, minus 4. So we get 2 over negative 6. And if you reduce it on both top and bottom by 2, so you're going to get negative 1 over 1/3. So now we have a slope, right? Slope is -1/3. We know x1, y1, 4 and 3. I use point slope formula, y minus y1 equals slope times x minus x1. Now throw in the slope. Okay, plug in the x1, y1. x1 goes here, y1 goes here. So you get a y minus 3 equal to slope is -1/3 times x minus 4. Yes. Now we distribute it. Okay, so we get y minus 3 equal -1/3 of x. -1/3 times -4 is positive. 2 negative turning positive. 4/3. Now you're adding 3 from both sides of the equation. Okay, add 3 here, add 3 on the right side. And from there, we end up with y equal -1/3 of x. And 4/3, adding 3, make 3 a fraction, 3/1. And the LCD is 3. So multiply 3 here, multiply 3 here. Okay. So end up with y equal -1/3 of x, adding 4/3 plus 9/3. So this turned out to be -1/3 of x, adding, now they are like fraction, adding the numerator, 4 plus 9 is 13/3. And we come up with a linear equation in the slope-intercept form. Okay? So slope here is -1/3, y-intercept is 13/3. Okay. All right. Or maybe you guys try this one, right? I give you a couple minutes. Quickly try this one. Write a slope-intercept form for the equation of the line through the point -2 and 5. And let me just okay, do that. Let me take the screenshot really quickly so to mark everybody attending the class, right? Okay. You can work on that question really quickly. All right, so let's take a look at the solution really quickly. So we are given x1, slope is given 3, x1 is given -2, y1 is given, that's 5.
Wait, you have to share your screen again.
All right, so it's gone. So let me share the screen one more time. All right, share screen. Here you go. How about now? It's good?
Yeah, all good.
Okay, all good. Perfect. So we are given all 3 numbers. So next thing you just have to plug in all those 3 numbers into the point slope form. Y minus y1 equals slope times x minus x1. Now throwing all the numbers into this, so it's y minus 5 equal to slope 3 times x minus -2. So 2 negative turn into positive. So it becomes y minus 5 equal 3 times parentheses x plus 2. And now we distribute it using some algebra. So y minus 5 equal 3x, adding 6. Now the very last step, right? You adding 5 from both sides of the equation. Now you get it, right? Cancel that. So y equal 3x, adding 11. So here we know slope is 3, y-intercept is 11. Okay. All right, so that's quick review. It should be, you probably see this a lot in the algebra course back in high school, you know. Again, so first chapter is mainly review with a little bit of application. You know, we're going to talk about a little bit more application in the second, from the other sections, section 1.8. So now let's look at this. Okay, look at the graph and then tell me which one is the graph for y equal to x plus 2. Any suggestion? No, okay, that's fine. So slope is here, slope is 1, right? Okay, y-intercept b is 2. Okay, so we can start with the y-intercept b, right? So definitely y-intercept b equal to 2. Also, this one works, right? And then this one works. The other two, we already eliminate 1 and 3. And then now let's use the slope equal to 1, right? Also, since slope positive, that means it's increasing line. And this one is decreasing line. So the answer should be 4. Okay, just based on this positive indicating increasing from left to right, right? So we can easily determine it's 4. Also, as you can see, from this point to this point, it's going to the right 2 units and then go up 2 units, right? So it should be, slope here is 2 over 2, going to the right 2 units and then go up 2 units. So 2 over 2, that's 1. And that's why the option 4 is the correct answer. Okay. So we just use a overall understanding of the linear equation, you know, to interpret the, to pick the right graph here. So on next few slides, some practice problems. And you also want to choose the most efficient method, the easiest method, and then solve and then graph the equation. So let's learn how to graph this, right? So you guys should try this yourself. Okay, first of all, graph this. Negative 3x but minus 2. I give you a couple minutes, quickly graph that. Okay, so let's quickly go over this. So here we are given two things, right? Slope, m is -3, and also y-intercept is -2. So we're gonna graph this. We first of all put down the y-intercept. So y-intercept is -2, so it should be located right here, -2. Change to different color. So right here, yeah, we get first point. Now we're gonna utilize the slope to generate another point on a Cartesian system. So here is -3/1. So this means go down 3 units, right? Down 3 and go to the right 1 unit. Okay. So that means we gotta go down 3 units. Okay. Just move this a little bit. -3, -4, -5. Okay, so we go down 3 units, goes here, and then go to the right 1 unit. So this is one unit. Yeah. So now we get 2 points, and then you just connect it. So the other order pair will be 1 and -5, right? So this y-intercept is 0, -2, -2, and then 1, -5. So you get that 2 points, connect them, extend it. Okay. So we come up with this straight line. Okay. So that's how you do this one. And next one, try this, right? You can use a X and Y intercept, right? Because it's appear in a standard form. All right. First of all, we find the X-intercept. Okay. So we're setting y equal to 0. So here, replace y value with a 0. So we get 2x plus 3 times 0 equal to 0. So we get 2x equal to 0. And divide 2 from both sides of the equation. X equal to 0. Okay. So the X-intercept is 0, 0. Secondly, with a y-intercept, we're setting x equal to 0, right? You're definitely going to get y equal to 0. So we set x equal to 0. So we end up with 2 times 0, adding 3y equal to 0. And this is 3y equal to 0. And divide 3 from both sides of the equation, y equal to 0. Again, 0, 0. So we do not get 2 order pairs. Instead, we get a order pair, same order pair. That's not sufficient, right, to graph the linear equation. So we need another order pair. So typically, what you want to do is you can set in when this happens, meaning both x and y-intercept occurs at the same place, which is origin. So in that case, we need another order pair, right? From there. So you can just setting, let's say x equal to 3 and solve for y, right? When x equal to 3, so 2 times 3 plus 3y equal to 0. We get 6 plus 3y equals 0. Then subtracting 6 from both sides of the equation, we get 3y equal -6. Now divide 3 from both sides of the equation, we get the result, right? So y equal -2. Here you go. So the second order pair we have is 3, -2. So now we have two order pairs, and then you can sketch the graph. 0, 0, and then 3. This 0, 0 is origin, right? Origin. And the other one is 3 and -2. 3, -2 is down here. So the other order pair is down here. Okay. So now again, you connect those two order pairs, you get a line. Okay. So that's how you do it. And this is a very special case because when you try to use X, Y-intercept, they turn out to be the same order pair, right? So you got to generate another order pair and to graph it. Any question on this?
Yeah, wait, why did you pick 3 again?
Oh, you can pick any number, but the 3 brings some convenience because you see, the coefficient in front of y is 3, coefficient in front of x is 2. So I just pick the other, you see, I pick the coefficient in front of the y. So
Okay.
you can pick 1, right? You can pick 2, but you have to deal with the fraction there. By picking the coefficient in front of the y, then we avoid the fraction. Very good question, though. Yeah.
Okay, thank you.
Number, theoretically, any number you like, right? You can pick 1, 2, 3, 4, any number you feel like you want to pick. No problem, right? But mathematically, that's always a easier way to do it. Okay. All right, very good. Now look at this, right? And this one, again, give you a couple minutes, graph it. Okay, this one, both X, Y intercept exist, right? They are distinctive, and you can use them to graph it. All right, let's quickly go over the solution. The first one, let's start with the X-intercept. By setting y equals 0, so y equals 0. So you get a 4x minus 0 equal to 5. So 4x equal to 5. And divide both sides of the equation by 4. X equal to 5 over 4. You want to turn into a decimal. This one is, you can turn into a decimal. It's 1.25. I guess decimal usually give you a better idea of the location of the number. So this is 1.25 and 0. Okay. It's first order pair, second order pair, y-intercept. We set x equals 0. 4 times 0 minus y equal to 5. And 4 times 0 is 0, right? So negative y equal to 5. Okay, so then we divide both sides of the equation by negative 1. Okay, or multiply both sides of the equation by negative 1. Equally good. Cancel the negative 1, y equal to negative 5. So the y-intercept is 0, negative 5. Now once you have both order pairs, then you just have to plot it. Okay. Different color to pinpoint the both points on the line. Okay. So here first x-intercept is located on the x-axis. And then this is 1 unit, that's 2 unit. And then 1.25 should be a quarter, right? A quarter right here. So this is 1.25. Should be a quarter of the entire unit. So right here. Okay. And then next y-intercept is negative 5. So negative 1, negative 2, negative 3, negative 4, negative 5. So this is another order pair down here. Once you have those 2 points, connect them, extend it on both directions. Okay, then you get a line. And again, this is an increasing line because it's moving up from left to right, right? Okay, so that's, yes. So far we're using 3. You can try the other 2, right, on your own. Okay, very similar to the one we just did. So I will skip it. All right. So now we are already used 3 different methods for graphing equations, right? Slope-intercept form. Okay, we know slope, we know intercept. We got using x-y-intercepts, and also using point-slope form, right? So 3 different major instruments we can use to graph the linear equation. And which form is used to graph x-y-intercept? Standard form, right? Meaning ax plus by equals c. This is what we call the standard form. So to quickly review of linear equations, slope-intercept form, slope of line, y-intercept, right? Both given. We have a standard form, ax plus by equals c. Both a, b, and c are integers, and they all positive. Okay, now a must be positive, right? A must be positive. Okay. And a point slope form. Okay. So we get a slope, and then we have order pair, a point. Then we get a point slope form. Yeah. Okay. So this is everything on section 1.6, and let's move on to 1.7. Okay. I just posted it, right? And very similar to the one we just did. It's review based. So far we talking about the current slide. Okay. Find the equation from 2 point. Okay. So we have a slope-intercept form. So this is one of the most popular form of the linear equation. So we normally go back to the slope-intercept form, no matter what other forms you have. Okay. Now here you go. We just need to let's just identify the slope and the y-intercept for each one of this. Start with this one, right? So the slope, once it's in the standard slope-intercept form, so the number in front of x, that's the slope. So slope here is -4. Then the number right after x, that's y-intercept, b equal 3. Okay. And the second one right here, and you probably want to rewrite it, right? So switch the order of the 5 and -12x. So this same thing as y equal to -12x, adding 5. Now it's easier to identify slope and the y-intercept. Slope is -12. Y-intercept b is 5. Okay. And the third one, again, it requires some work. First of all, you need to isolate the y, meaning we're subtracting ax from both sides of the equation. Okay. We do that, and now we get we come up with y equal to negative ax minus 3/4. Now it's in the slope-intercept form. Then the slope is the number in front of the x, which is -8. Y-intercept is number right after x, including the sign, so -3/4. Okay. And this one requires a little bit more work. First of all, you subtract 4x from both sides of the equation. Okay, and we end up with -2y equal to -4x, adding 10. Okay. Now, in order to get rid of the coefficient in front of y, we divide every single term by -2. Very crucial, right? In order to divide a number, you have to divide a number across the left side of the equation and the right side of the equation. And this turned out to be y equal to 2x minus 5. Okay. Now, once we have that, now we know the slope is 2. Y-intercept is -5. So again, no matter what form you have, you always go back to the slope-intercept form to locate the slope and the y-intercept. And this one has no y-intercept, right? You can just put 0 there. 1/3 of x plus 0. Then we know that slope is 1/3. And the y-intercept b is 0. That happens, right? This line passing through the origin. So that's why the y-intercept is 0. Okay. The last one, this one has no slope, but we can manually create the slope, right? So y equal to 0x adding 5. Now it'll be easier to identify this. Okay, so we know that slope must be the number in front of x, so slope is 0, and then y-intercept is 5. And this one has no, this one is called horizontal line, and that's why the slope is 0, right? It doesn't go up, right? Go up or down, it just remain flat. Okay, and this is how we identify the slope and y-intercept given the equation in any form, right? You can always convert it back to the slope-intercept form and then locate the slope and y-intercept. Okay, now find the y-intercept, find the equation of the line given the graph. So now it's different, right? You're going backwards. You are given a graph of the line, and you're going to go back to the equation. One thing you can do is, first thing you can do is locate the y-intercept from the graph, and also you count the slope from the graph using vertical change over horizontal change. Also, you can call that rise over run. Okay, changing y over changing x, right? Locate 2 points, and let's find out the vertical change within those 2 points and the horizontal change within those 2 points. Then find out the slope. And once you know that slope and the y-intercept, and you have the equation of the line. Okay. Now look at this, right? So we are given this graph right here, and we know the y-intercept immediately, right? From the graph, y-intercept is 3, so this is y-intercept. And y-intercept turned out to be 0, 3, meaning b equal 3. So we know one thing. Another thing is we need to find out the slope. So from this point to this point, that means we got to go up 3 units and go to the right 2 units. So slope is vertical change or rise over run, right? Go up meaning positive 3 units, and then go to the right meaning positive 2 units. So slope turned out to be 3/2. So we know slope, we know the y-intercept. Now you know the equation of the line, right? Should be that. Okay. So this is how you going backwards, having the graph of the line, and then come up with the equation of the line. Okay. Example 2, very similar, right? We are given the y-intercept here. So b is 1, positive 1. And slope, you see, from this point to this point, right here, it will go up 1 unit and go to the left 2 units. go up 1 unit, rise over run. Go up 1 is positive 1, right? Go to the left, it's negative 2. And slope is negative half. As you can see, this is a decreasing line. That also matches with the slope. Okay, so y-intercept 1, slope negative half. Then the equation of the line is negative half x plus 1. One more example, right? So this one, you see, is a horizontal line. That means it doesn't go up or down. And the y-intercept here is 4, right? This is 4 units. 1, 2, 3, 4. This is 4. So the b equal to 4. And then the slope is rise over run. Let's say from this point to this point, there's no rise, right? Rise 0 unit. Run to the right 1 unit. So 0 over 1, that's 0. Okay, so we know the slope here must be 0. And y-intercept is 4. So we have that. Okay, so 0x plus 4. That turned out to be y equal to 4. Okay, and that's exactly the equation for the horizontal line. And what if I give you something like we have another line, right? Something like that. Then what happens? How do you present that line? Let's say this is negative 4 here. Any suggestion? And we call this vertical line. Okay. Vertical line has no slope, right? Slope is undefined because there's no horizontal shift, no horizontal change. So you're gonna have a vertical change, let's say from this point, let's say from this point to this point, the vertical change is going down 1 unit. So slope equal -1, and the horizontal change, there's no horizontal movement, 0. So this turned out to be undefined. So that's why for all the vertical lines, the slope is undefined. And then the way how you write it is just x values, right? Because x value always remains the same. Here, x value always remains as -4. Okay, so that's how you identify the vertical line. But try to make sense of this, right? Why the slope is undefined for the vertical line? Because by definition, there's no horizontal shift, no horizontal change. So the denominator is always 0. So any number by 0 is undefined. Okay. So now using the point slope formula to find the equation of the line. So you need to have given point, okay, and then also slope. All right, so one more time. We have this, we went over a similar question in section 1.6. So one more time, the slope is -2, okay. And then x1 here is 3, y1 here is -5. And we'll find the equation. So x1 is 3, y1 is -5. So very quickly, y minus y1 equals slope times x minus x1. And we throw in all the numbers, we get a y minus -5. Here, y1 is -5. And the only tricky thing about this is sign, right? Just be careful about the sign. Make sure you write down all the sign needed. And slope is -2, x minus 3. Now simplify, right? Y 2 negative turn into positive, y adding 5 on the left. On the right, you distribute it. You get -2x adding 6. Now from there, adding 5, subtracting 5 from both sides of the equation to get to the final solution. So eventually we end up with the y equal -2x and then adding 1. Here slope is -2, y-intercept is 1. Finally, equation of the line given 2 points. Again, we went over a similar example. You need to find the slope really quickly, right? Using y1 x1, y2, x2. So throw in your numbers into the formula, get a slope, and use one of the point, typically x1, y1, and use the point slope formula to get the equation of the line, and we got it. So here we go. This is a typical example. Write the equation of the line that goes through this point. So you can label the first order pair x1, y1. Second order pair x2, y2. First thing, we find the slope. Slope should be y2 minus y1 over x2 minus x1. Throw in the number, so it's 4 minus 2 on top. On the denominator is 5 minus 3. So this is 2 over 2, turned out to be 1. Okay. So slope is 1, and we know x1, y1. Now we have y minus y1 equals slope times x minus x1. Point slope form. I'm plugging the numbers. Y minus 2 equal to 1 times x minus 3. And simplify, distribute it. So y minus 2 equal to 1x. So omit the 1. 1 times negative 3 is negative 3. So after that, we add in 2 from both sides of the equation. Then eventually we end up with y equal to x minus 1. So here slope is negative, 1, positive 1, and the y-intercept is negative 1. All right, so that's, and given the equation of the line, find the equation of the line given the x and y-intercept. So x-intercept is 4, so order pair 4, 0, right? Y-intercept is negative 2, so 0, negative 2. And then here we are given 2 order pairs still, right? So we're using the slope formula. So label this x1, y1, this x2, y2. And then throw into the equation. So y2 minus y1 over x2 minus x1. Then we have this negative 2 minus 0 on top. And the denominator is 0 minus 4. So we have a negative 2 over negative 4. So simplify, you get negative positive half. Okay. So slope is half. And here we know the y-intercept b is negative 2, right? And just use slope-intercept form, mx plus b. Slope and the y-intercept throw into the equation, we get half x adding negative 2. And once you simplify, you get y equal to half x plus minus is minus 2. Okay, so that's how you come up with the equation of the line given the x, y intercepts. Okay. All right, so now I want you to try this. Write the equation of the line with the x-intercept 3, y-intercept 2. Try that really quickly. Give it a couple minutes. All right, so let's go over the solution. X-intercept is given in this form, right? So 3, 0. So we have first order pair 3, 0. The y-intercept should be this, x equals 0, 0, 2. So if you want to label this x1, y1, this is x2, y2. Okay, we do that. The next thing is find the slope, right? Slope is equal to y2 minus y1 over x2 minus x1. So this turned out to be 2 minus 0 over 0 minus 3. So this is 2 over negative 3. So slope is negative 2/3. Now we have that. Next thing is find out the y-intercept. And we know in the y-intercept b equal to 2. Okay. Then we just plug in both numbers into the slope intercept form. So this is y equal to 2/3 of x adding 2. Okay. So that's how you end up with the equation of the line with a given x and y-intercepts. Okay, so this is everything on section 1.7. Again, we went over most of the stuff earlier, which is good. Okay, from the section 1.6. Now let's move on to 1.8 and let's start talking about some of the applications, right? Let me open the PowerPoint from 1.8. Okay, you should open that as well. Okay, let me share that. Share the screen with you. Stop share the screen. Okay. All right, so let's start with this example on function notation. Okay. In section 1.8, never editing. Now we actually mentioned about the function notation, right? So the application of the linear function usually deal with the function notation of the linear equation. So that's first of all, let's take a look at this. Determine if each relationship represents a function. And how do we determine the function? Anybody still remember? What if a relation is a function? What's the key aspect of that? Key element in determining the function? All right. So the most important thing is one-to-one relation, right? One-to-one relation. One-to-one relation, meaning one x value should only produce one and only one y value. One x value could only produce one and only one y value. Okay, so this is the most important element in function notation. One x value could only produces one and only one, right? Cannot produce two or more y value. Okay, so this is most important thing about the function. And as you can see, so when we plug in one x value here, when x equal to 1, y value is 1. Okay, when x equal to 2, y value is 8. So one unique x value only produce one unique y value. So the first one is a function, right? So this one, yes, it's a function. Okay, because it's one-to-one relation. You can also write it as order pair 1, 1, right? 2, 8, 3, 27, and it's 4, 64. So 1x produces one and only one y values. And if you look at the second one, what do you think of the second one? Any idea whether it's a function or not? Is it one-to-one relation? And how do we know that? And one way to figure out that is by selecting, let's say selecting a particular x value, let's say x equals 0, let's see what happened to the y values. So y value equal 3 times 0 squared minus 1. And this is 0 minus 1 is negative 1. So one x value 0 produce only one y value, negative 1. And you can also pick another x value. Right? Let's say x equal to 1. Let's see what is y value. Y value equal to 3 times 1 squared minus 1. And this turned out to be 3 times 1 squared is 3. 3 minus 1, that's 2. Okay, so again, it's 1 to 1. One x value produces only one y values. So this is indeed a linear function. Not a linear function, right? But it's a function. Okay, this is what we call quadratic function. All right. And the third one, function is still a quadratic function, right? F of x equal to x squared plus 2. And you want to find out what is f of 0, f of 3, and f of negative 2. So for f of 0, go back to the original function, replace x with a 0. So we get 0 squared adding 2. So 0 plus 2, that turned out to be 2. So the correct answer is 2, right? For f of 0. Okay, f of 3. So now go back to the function itself. Whenever you see x, it becomes 3. So it's 3 squared adding 2. So it's 9 plus 2, 11. So that's why answer is 11. Okay, and the f of negative 2. Now when we see the x value, it becomes negative 2. So and I put negative 2 in parentheses. So negative 2 squared adding 2. Negative 2 squared is 4. 4 adding 2 is 6.
Professor?
Yes.
Okay, I'm a little bit confused on this. So if you're using that same function are you using this, wait, I'm getting confused. I'm trying to see if you're using the function for 2 or for 3.
Right. We stick with the same function, but the x value changes, right? From case to case. The first case, x value is 0. So that's why we replace x with 0. So
oh no, I see it. I got confused because I was looking at the one that's circled on number 2, but I see number 3 now. I just couldn't tell with all the writing. Okay.
Good.
Yeah. Thanks.
Okay. Perfect. So so the f of negative 2 turned out to be the 6, right? And again, it's 1 to 1. So one x value produces one and only one y value here. So it is a function. Very good. So now let's move on to specific idea of linear functions, right? We use this f of x equal mx plus b, right, to represent a linear function. We mentioned that last Wednesday. And here, this one function notation, and we note f of x is the same thing as y, right? They are equivalent. Just different notation. When using y is a standard notation, and if you're using the f of x is function notation. Okay. Linear function and function notation. Okay. I just mentioned that to you. And linear function could be described by a linear equation, but with a function notation, right? Function notation we typically use f of x. Okay. And it's read as f of x. F of 1 is read of f of 1. Okay. And the graph of the linear function is a line. The linear functions appear in this form, has a slope m and a y-intercept b. Okay, those two are most important thing to identify the linear function. All right, any question on the function notation? And still, right, one x value only produce one and only one, or creates one and only one y value. That's most important nature, right? That's usually we utilize that to determine the function, okay? Whether or not a relation is a function. So we have all these equation could be a relation, but not all of them are function, right? You will see in a second. Okay, let's see. So identify linear function, determine whether the function is a linear or not. What do you think? f of x equal 2x cubed. Is that linear? Okay, definitely it's not linear, right? It's a cubic function, right? This is a cubic function. Because the power of x is to the third power. And this is one of the member from the polynomial families, right? This is what we call a polynomial function. This is third degree polynomial function. Polynomial function has a lot of different derivatives, and linear function, quadratic function, cubic function, they all part of the polynomial function family, and depends on the power of the x values, right? And you determine whether it's first degree, second degree, third degree. And here, this is what we call third degree polynomial function. And all of these are function, right? All the polynomial functions are function. Okay. All right, so if you want to double check whether it's a based on the important element, meaning let's determine the order pairs, right? Of x. Okay. We can come out with some order pairs here and determine that. Let's say 5 order pairs. I'm going to pick some of the smaller values, x from -2, -1, 0, 1, 2, right? So we're picking the x value in the sequential order from -2 to 2. And you want to find out the y value. First of all, f of -2 becomes 2 times -2 to the third power. And -2 to the third power is 1/8, right? So you can also make it a fraction. So this will become 2 over 2 cubed, right? So flip the -2 to the 8th. Okay, actually it's not, my bad. This is not a power, so we cannot do that. We can just expand it. We can just expand directly. So -2 to the third is -8. So 2 times -8, and this turns out to -16. So the y value here -16. So it's 1 to 1, right? Y-x value only produces one y value. And secondly, f of -1 is 2 times -1 to the third. So all the negative numbers to the r power remain negative. So here is 2 times -1, and that turns out to be -2. Again, still 1 to 1. Y-x values produces one and only one y value. And f of 0 here, 2 times 0 cubed equal to 2 times 0, that's 0. Okay. And f of 1 is 2 times 1 cubed. And since it's positive number, so we don't have to put in the parentheses. So 2 times 1 is 2. And the last one is f of 2 times 2 cubed. That's 2 times 8, 16. Okay. And again, all of these are 1 to 1. And let me give you an example which is not 1 to 1, right? So far, we all looking at the 1 to 1. Let me give a very simple example. Let's say x equal to y squared, right? Now think about this. If you plug in a particular x value, let's say x equal to 1, then what happened to y value? So 1 equal y squared, right? That means y squared equal to 1. And if you're taking the radical here, taking the square root on both sides of the equation, so we get plus minus radical 1. And then the y value is equal to plus minus 1. Now, as you can see, one x value produces two y values. That's why this is not a function. So for this particular notation is not a function because one x value produces two y values. Okay, a very concrete example, right, to show you when it is not a function. Okay. Now, determine whether the function f of x equal -2x plus 4 is linear. In order to determine whether it's linear, first of all, the power of x must be 1, right? That satisfies. We can also identify slope is -2, y-intercept is 4. Now we know that it must be a linear function, right? So this is a linear function. The power of x, that's first thing you check. And then second thing is checking the slope at the y-intercept. As soon as all those elements are presented here, then we know that it's a function. It's a linear function. Okay. Now think about this. Let's try to write an equation for a linear function, right? You are given this t-table. We call this t-table. The good thing about t-table is we have order pairs here, and the first order pair is -3, -8, -1, -2, okay, 1, 4, and 3, 10, right? And based on this order pair, we know it is 1-to-1 because one x value here only produces one and only one y values. And let's see how we come up with the equation of this linear function, right? So still we're gonna just picking two order pairs, right? So picking these two, let's say last two. And then you label this x1, y1, x2, y2. Then first of all, we find this using slope, y2 minus y1 over x2 minus x1. Find the slope first, okay? Label this x1, y1. This is x2, y2. So this is gonna be 10 minus 4 over 3 minus 1. So this is 6 over 2, which is 3. Now we know slope is 3, and we know x1, slope is 3, x1 is 1, y1 is 4. And we're using point slope formula. So y minus y1 equals slope times x minus x1. And throwing on numbers, y minus 4 equal to 3 times x minus 1. Distribute it, we get y minus 4 equal 3x minus 3. Then adding 4 from both sides of the equation. And this turned out to be y equal 3x, adding 1. And then now we're going to turn back to function notation. Then y becomes f of x. So in order to write it as a function notation, this is a needed step, 3x adding 1. I come up with the equation, right, for the linear function. Okay. And this, that's how you do it. Now, I want you to try this one yourself, right? And you're going to write it as a linear function, right? Again, using the t-table and come up with a linear function here. Okay, give you a couple minutes to try that. It's the same procedure like what I just did. Pick any 2 points here. Okay, so let's go over the solution. You can pick any two order pairs. I will pick the first two, right? So first two will be 0, 5, and then 1, 6. And the good thing about the first order pair is when x equals 0, that's y-intercept, right? So we know that b here equal to 5. Okay, so we just have to find out the slope here. So x1, y1, x2, y2. So slope equal to y2 minus y1 over x2 minus x1. This turned out to be 6 minus 5 over 1 minus 0. That it's 1 over 1. 1 over 1, that's 1. So we know slope is 1. Y-intercept is 5. Now we can write the equation in the slope-intercept form pretty quickly. So this is y equal to 1x plus 5. That turned out to be y equal to x plus 5. And again, we have to write it as a function notation, right? F of x equal to x plus 5. So the last step is very crucial, right? Turning from the standard notation to the function notation. So we get that. Now let's take a look at one of these applications. So it's about a video club costs $15 to join. So each video that is rented costs $1.50. Find a rule for the linear function that describes the total cost of the renting videos as a member of the club, and then find the total cost of renting 12 videos. So first of all, we need to define a couple of things, right? Define the dependent variable and an independent variable. So here, let's define independent variable x, right? It should be the number of video rented, right? Rented. And then define the dependent variable f of x, or if you want to use y or f of x, either one you like, right? And could be the total cost, right, of all those rented videos, total cost. So very important to define both, and so we have clear idea of what we deal with. And then first of all, the total cost comes from two parts. Okay, there's a fixed cost of $15 to join, and there's a variable cost of $1.50 per rented video. So it should be 1.50 times x, adding total the fixed cost $15, and that will give us the function notation for this scenario. Okay. So the final function notation should be this, plus 15, right? And then once we have this, and now the second problem is renting 12 videos. That means x equal to 12. When that happens, let's find out the total cost. So we're talking about F12 here. So this is going to be 1.50 times 12. X becomes 12, adding 15. And then 1.50 times 12, that's $18 plus $15. Total will be $33. So it costs a total of $33 of renting 12 videos. Okay. Now I want you to quickly try this one, right? Very similar one. Give a couple minutes, come up with define the variables, both variables, find out the function notation of this linear function, and then also figure out the cost of buying 10 books. Okay. So first of all, we define the independent variable X will be number of books purchased. Number of books purchased. And then the Y value or F of X will be the total cost, right? Total cost of renting, of purchasing those books, total cost. So the first thing is, let's find out the function notation of this. So F of X should be two cost, variable cost. Each one cost, each book purchased costs $2. We'll have X amount of books, right? 2X, adding the fixed cost membership fee, right, which is fixed cost of $20. Then we get a function notation. Now you want to find out the total cost for buying 10 books when X equal to 10. F of 10, 2 times 10, adding 20. So it's 20 adding 20, that's $40. So total cost of buying 10 books will be $40. Okay. Now let's take a look at the following examples. Determine whether each function is linear, right? So again, they are given the functions. Following, they're all functions, but you have to figure out whether they are linear functions. For part one, we have a linear part of the function, right, which is 3x. However, we have quadratic term, 4x squared. So this is not a linear function, right? It's a quadratic function, not linear. The second one is a linear function because we can easily identify slope. We can identify y-intercept here, and then the power of x is 1. So this is definitely a linear function. And the third one, we are given a graph here, and you want to find out the linear function associated with this graph. And first thing is we identify the y-intercept here, right? It's -1. And then let's find out the slope using the rise over run, right? So it rise 1 unit, run to the right 2 units. So slope should be 1/2, half. Y-intercept is -1. So the function of slope intercept form should be mx plus b. Plug in that, so we get half of x, plus minus 1 is -1, and we turn into function notation f of x equal to half of x minus 1 as a final result. Right? Based on the graph we are getting here. All right. Any question on this? So definitely this is a linear function. All right. Now I want you to try this. This is exercise, and you try this too, right? Write the roof of each linear functions. Try this and try question 2 and 3. Okay, I'm gonna give you 5 minutes this time to complete this. All right, so let's go over the solution, right? So first one for question 2, based on this order pair, we know that y-intercept b should be -1. So if you want, you can list both order pairs 0, 1. I'm using 0, -1, and then 3, 8 to find the slope. And since we know y-intercept, then we will be easily identify the linear function here. So slope is a minus -1 over 3 minus 0. So this is 9 over 3, which is 3. Now we know slope is 3, y-intercept is -1. So the function notation should be, I will do it quick, right? So it will be fx equal mx plus b. So it will be 3x adding -1, and simplify, it will become 3x minus 1. So the function notation should be f of x equal to 3x minus 1 for this. Okay. And then question 3, Android sell toys. So pay $60 to rent the booth. Material for each toy at $4.50 per toy. So the function notation should be 4.50. That's unit cost, right? Times total toys, right? Each toy costs $4.50 to make, and $4.50 times X amount of toys, adding the fixed cost of renting the booth, $60. Then we get a function notation of this. And if we sell 25 toys, f of 25 should be 4.50 times 25, adding 60. And let's see what that is very quickly using the Excel or calculator. That turned out to be $172.50. That's the total expense of selling 25 toys. Okay. All right. Any question on this section 1.8? It's all good. So now let's go back to the homework assignment, right? Before we move on, I want you, let's go to section 1.6, 1.7, 1.8. See anything, see any interesting question from there. And so you want to open a textbook, right? Go to our Blackboard course, open a textbook. Let's go from there. And let's go to section 1.6, 1.7, and then 1.8. Just scroll down a little bit. I think this was some of the questions from 1.6. They're all very standard questions, right? I guess we can skip some of this. Yeah, so graph the following equations, and you know what to do. So any question you want me to go over in the exercise 1.6? Only the even ones, right? Okay. Anything here? All right, and let's look at 1.7. Okay, so you are given two order pairs. You want to graph it, right? Get a slope, find the y-intercept, and you go from there, right? Then you can easily find the equation of the line. Okay, I think this is also straightforward. I think let's focus on 1.8. There are some application problems here, which is fairly interesting. Let's go back to the exercise in the back. of the, yeah. Okay, so this question number 2. And let's look at the question number 2. Okay, and I'm going to copy this and paste into the note. So it's a dosage of medicine, right? It's linear with the weight of patient. There's a minimum dosage onto which is added per pound dosage. You find that your dosage at 110 pounds, it's 48 milliliters. Your brother's dosage is 170 pounds at 66 milliliters. You would like to have an equation that will relate the dosage of to the weight of the patient. Okay, then we need to define a couple things: independent variable and dependent variable, and go from there. Okay, so let me put into the note, and let's take a look at it together. So this is a apply problem. If you're in the nursing field, you know, they have to deal with this on a daily basis and deal with the dosage, right, of the patient. Just change the fonts a little bit. Hold it. Change to 22. So we need to calculate a couple of things. First one, part A is, let's calculate, okay. Part A is define a variable X and then a variable Y, right? It's right here. Okay, let's define a variable X. Okay. So A, what do you think? Any suggestion? What will be the variable X? Which one should be independent variable? Is it the weight or the dosage associated with the weight? The weight of the patient? Weight, right? Very good. It should be the weight, right? Weight doesn't depend on anything, right? Weight is anybody's weight is their own business, right? So it doesn't depend on anything. So X represents the weight of the patient in pounds, right? Very good. And how about the independent variable Y or f of X? Should be the dosage, right? Dosage associated with each weight. Dosage, okay? In milliliter, okay? L represent milliliter. So we define both X and then Y independent. This is part B, right? And part C, the equation in the form of Y equal mx plus B. So since we know we define X variable and Y variable, so we basically have two order pairs. First order pair is 110 pounds associated with 48 milliliters and 170 pounds associated with 66 milliliters. And based on those two, we'll be able to find out the slope first. X1, Y1, X2, Y2. So here the slope is Y2 minus Y1 over X2 minus X1. So it will be 66 minus 48 over 170 minus 110. And on the numerator, 66 minus 48, that's 18. On the denominator is 60. So this means it's 0.3. And the way how we interpret it is 0.3 milliliters per pound, right? Meaning as the patient's weight increasing by 1 pound, then the dosage used will go up by 0.3 milliliter. That's the interpretation of the slope. I think that's part D. Let's see. The unit of the slope. Unit of slope must be milliliter per pound. Okay. I'll put in the abbreviation should be ml per lb. Right. Okay. That will be the unit for the slope. Pi in the unit of b and the interpretation of the b. That means we still need to find out the b. We haven't found out that yet. So let's find out the b here. So here we use the point slope formula. Y minus y1 equals slope times x minus x1. Slope is 0.3. Y1 adds 48. So y minus 48 equal 0.3 times x minus 110. Okay, and then from there, let's find out the equation of the line. So y minus 48 equal 0.3x minus 33. And adding 48 from both sides of the equation, and y equal 0.3x, adding 15. Now we know that here the y-intercept, so from here we know that y-intercept must be 15. But how do we interpret it? Okay, so pi is about interpretation of the y-intercept b. Any suggestion? Interpretation of b.
Is it the minimum dosage?
Very good. Yes, exactly right. Perfect. So minimum dosage, right? So B indicates minimum dosage. So no matter how light is your weight, right? Even though it's below the minimum, below the average level, you're still gonna need a minimum dosage, right? Of 15 milligram. So even for maybe for child or for like for the underweight people, they also need a 50 milliliter minimum dosage. Okay, that's pi E. And then pi F, what is the dosage for 165-pound patient? So this is very specific question, right? So what if you have a patient which is 165 pounds? That indicates X is 165. Okay. Now, utilizing the function notation, we're looking at F of 165. That means it's 0.3 times 165. Go back here, adding 15. And let's find out the total dosage for this 165-pound patient. So 0.3 times 165, adding 15. That turned out to be 64.5 milliliter. So that means the dosage needed for this 165-pound patient is 64.5 milliliters. Okay. Any question on this? Okay, this could be an actual problem from real world. Okay. Let's take a look at any other questions here. And you need to work on all the other questions, right? You need to complete that. Okay, maybe that's, yeah, machine. Maybe let's take a look at, let me see, any other interesting questions. Okay. Let's just maybe work on one more question, which is this one. And after that, I'll let you go. Okay. So we have a machine depreciate linearly, and it's worth $120,000 when it's 2 years old. It's worth $90,000 when it's 4 years old. And we want to find out what happened here. All these different things they're asking. Okay. So basically, this independent variable must be time t, right? So pi x should be age of the machine in years. Okay, that's first thing we define. Second thing, y variable or dependent variable. What is it? Okay.
Share the screen.
Okay. Oh, I forget to share the screen. Okay. All right. Thanks for the reminder. All right. So can you see the screen now?
Yeah.
Okay. Very good. So a couple of things, right? So the two variables here. First variable is age of the machine. So we define as a x variable, and second variable is a y variable. So it's the value of the machine, right? In dollar values, right? In dollar amount. Okay, so we define those both. And second thing is the unit, right? The unit age of machine will be years, right? And unit for the value will be dollar amount, right? Okay. And part C, they're asking for equation in the form of y equal mx plus b. So again, we have two conditions. First condition is this. Second condition is $90,000 when it's 4 years old. So first condition is translating into the order pairs will be 2 associate 120,000. Okay. And the other one is 4 years old, it becomes 90,000. Meaning within 2 years, the value of the machine go down $30,000. So this is x1, y1, x2, y2. Now let's find the slope, right? So slope equal to y2 minus y1 over x2 minus x1. So 90,000 minus 120,000 and dividing by 4 minus 2. So this turned out to be negative 30,000 by 2. So, and this result is negative 15,000 per year, right? If you want to put in the unit for this. And the interpretation of this, so that's just, first of all, let's complete the whole question before we jump to the interpretation. So next thing is interpreting, let's find this equation first. So we have this slope now, and we have x1, y1. So using point slope formula to find out the equation of the line first. So slope is negative 15,000. X1, that's 2. Y1, that's 120,000. Okay, so now using y minus y1 equals slope times x minus x1. And again, throwing everything into that. So you get y minus 120,000 equal to 2, slope is negative 15,000 times x minus 2. And distribute it on the right hand side, y minus 120,000 equal negative 15,000, x adding 30,000. Okay, now we're adding both side equation by the constant 120,000. Okay, now we get an equation in the slope intercept form. Okay, so it becomes y equal negative 15,000, x adding 150,000. So if you want to turn it into function notation, it will be f of x equal to negative 15,000, x adding 150,000. Okay, so you have all of that. Now let's go back to interpret this slope here. Okay, part D is interpreting the slope. Anybody want to give a shot? Unit of the slope and then interpretation. The unit of B, the unit of slope is dollar per year, right? Okay, pi E. And also let's try to interpret this slope. Anybody want to give a shot? Slope is negative 15,000 per year. What does that mean? Okay, no problem. So as the age of the machine increased by 1 year, then the value of the machine will go down 15,000. Okay, that's interpretation. As the age of the machine increased by 1 year, the value of the machine go down by $15,000. And that's interpretation of the slope. Now let's look at the y-intercept B, right? The unit of the B should be dollar amount, right? B here is 150,000. And what will be the interpretation of that? Any guess, suggestion? Okay, so the interpretation of the y-intercept B here should be the initial value or the original value of the machine. So initial value of the machine. Meaning when they purchase the machine, how much does the machine cost, right? This is the initial value of the machine. Okay, and that's the interpretation of the y-intercept B. And you want to find out also F, how much will the machine be worth when it's 8 years old? So we can easily plug in the 8 into the function notation. F is when x equal to 8. Now we have f of 8 equal to negative 15,000 times 8 plus 150,000. So this is negative 120,000, adding 150,000. And that turned out to be $30,000. Meaning after 8 years, the machine is worth, the residual value of the machine is $30,000. We call this residual value, meaning remaining value, right? Okay, so I guess I will stop here. Okay, so any comment, any question before we end the session? Okay.
Yeah, I just want to know what is all going to be due on Friday. Just want to confirm that.
Friday will be the first 2 projects, right?
Mm-hmm.
Finish the first 2 projects by Friday. Yeah.
Okay, that's all. All right.
That's all. Yeah. Okay.
All right. Thanks,
Right.
Professor.
No problem. Okay. I talk to you guys on Friday.
Professor, if you could repeat that.
Huh? Yeah. So the first couple projects will be due by Friday, right? Okay. So
What
we have
project
project
due
number
by Friday?
Excel project.
Oh, okay, okay.
Yeah. You already submit. Most of you guys already submit the first project, right? So you just have to worry about the second project. Yes.
When will the first test be?
First test on week 5. So after we finish this, just look at the schedule really quickly. Let me just share the screen with you. So
Is that next week?
next week? No, not next week. Definitely not next week. We maybe a couple weeks down the road. But yeah, I'll usually give you heads up a week before, right? You can prepare for that. And also, I think I post the review sheet for the exams.
Okay.
Yeah, so it's right here. So you can just look at the review for exam number 1. Okay. Yeah, so and then the detailed schedule is in the syllabus. Okay. But definitely not next week, right? No, definitely not next week. Maybe a couple weeks down the road. We're still on chapter 1. We just finished chapter 1 today. And next week we will start on maybe on Friday, we maybe just do a little lecture on chapter 2. Introduce on the exponential functions. Otherwise and then next week we continue on chapter 2. Yeah. Okay. All right. Any other questions? All right, no problem. So any questions, feel free to email me and I'll respond to your email. So in that case, I will end the session. I talk to you guys on Friday. Bye-bye, guys.
Bye.
Thank you. Bye.
No problem. Bye-bye. Okay.